Welcome to Japan! Yay! 皆さん、JAXA が主催するアジアントライゼロ G をご存知でしょうか。アジア各国太平洋地域の若者から募集した宇宙実験を宇宙飛行士が希望実験棟で行う取り組みで、今年1月に行われたアジアントライゼロ G2022 では6つの実験テーマが選ばれました。宇宙ベンチャー企業デジタルブラストでは見事実験テーマが選ばれたタイのお二人に対し、アジアントライゼロ G への参加にかかる航空券や滞在費などをサポートしました。今回はそんなお二人とタイ国立科学技術開発庁、通称NASDAの職員と一緒にアジアントライゼロ G でどんな実験をしたのか、さらにタイの宇宙活動についてなどじっくりとお話を伺います。Okay, first of all, could you introduce yourself, Prem-san? It's first, okay?
Hello, my name is Jinna Iwatana. My nickname is Prem, and I moved to study at Mahidol Vidyanusaran School in Nakhon Pathom near Bangkok, the capital cities of Thailand. And I am the final year student of the senior high school. Yeah.
Thank you. How about Pai-san?
Hello everyone. My name is Intilaporn Chowdi. You can call me Pai. Yeah, I have just graduated from my Faculty of Pharmacy at Thammasat University, and I have worked for a few months in a department of Thai government. Now I'm 24 years old. Yeah, thank you.
Thank you.
はい。こんにちは。My name is Beng Paritat. I'm a project manager for space education in the National Science and Technology Development Agency or NASDA, Thailand. I'm work for collaboration program with the Japan Aerospace Exploration Agency or JAXA for a long time. Let me talk about a little bit about my company, NASDA. NASDA or the National Science and Technology Development Agency. We are biggest science and technology research area in Thailand. NASDA is perform and use about the science and technology in Thailand for help Thai people to make a good life, and we support the Thai business, Thai industrial for use science and technology to help them.
Thank you.
Thank you.
Mm-hmm. The day before yesterday, you've joined Asian Tri-Zero G, which was held at Tsukuba Spaces of JAXA. You participated in the event as a representative from Thailand. What made you think about joining that?
For me, from my background, I interested in the space and astronomy in the sci-fi fiction or my favorite scientists. Yeah, so when the project has announced, so I intend to be apply into this project. Yeah, and I think that if I can include with other country friends, I can exchange a lot of things. Yeah.
For me, I'm self-motivated to conduct experiment or laboratory in school, science. And when I see this program, and it's very a good opportunity, I think, because it's very rare for us, and I think for all of students to get our experiment to conduct in space. Really, yeah, it's very rare. And so when I heard of this program, I'm not hesitant to join, because I think if my proposal will be chosen, so it will be so lucky, and yeah, it's a good opportunity.
How many applicants are there?
The total applicants for apply to Asian Tri-Zero G program this year is 480 applicants from around the Asian country. For Thailand, we have around 400 participants from Thailand to apply Asian Tri-Zero G program, and we have 172 experiment ideas from Thai students.
I understand. Okay.
Then, could you tell me about your experiment?
Well, my experiment is entitled Water Sphere Disturbance in Zero Gravity. Start with the motivation. So, first of all, I think like water is very important for humans to be survive, and water has special property in microgravities. So in the right picture, you can see that the water can form into a spherical shape because the dominant of surface tension in microgravity, because there is no gravity that pull the water down to be like a drops. Yeah. So and also there are no hydrostatic pressure, the pressure which varying with depth, and also there is no buoyancy, so the water will not exert any force on the submerged objects in the water. And also, and with this like special property, I think it's very insightful that we can try to conduct experiments in the space. So I'm curious that what will happen if water receives like a force that we call impulse from collisions, and also the shear force from spinning objects. So we'll study the behavior of waters and the system. Yeah. And this is the schematic model of my experiments. It is the first part, and there is also the second part too. So the first one, I will create. So no, the astronaut have to create the spherical shape water. So on the metal white hoop, yeah. And after that, the astronaut will apply a force on the ball. So we have, actually there are three types of ball. The first one is the steel ball with the highest mass, and also the wooden ball, and also the other one is the wooden ball with waterproof on the surface. So we'll see what the difference between these three. So the astronaut apply the force on the balls, and so make them like move forward to collide with the water. Yeah. And my expectation is that if the ball with small mass, which is the wooden ball, so result in they will have like small momentum, because momentum is depend on mass and velocity, but we apply the same velocity. So yeah, it depends on mass. So if it has small momentum, it will maybe bounce back because the surface tension of the water will be strong enough to like push them away in the same direction. But if it have large momentum, for example, steel ball, and it will get inside the water sphere because it have like enough energy. So another factor is the waterproof on the surface, that we'll see what's the difference. And the other experiments, sorry that very long. The second experiment is we will observe the shear force by contact the water with the spinning objects, which is the tip top. And tip top have a special property because it can flip when we spin it fast enough. So the reason behind this is the friction between the surface of the ground and the tip top. Yeah. So this friction will reduce the rotational kinetic energy and increase the potential like energy. So make the center of mass higher. So it's flipped like this. Yeah. Anyway, okay. Then we will spin this one. Simply spin it on the water, and then so I expect that. On Earth, I think that this tip top maybe can tilt, but the energy is not enough to flip because the water is that have a viscosity, right? So maybe it's just tilt a little bit and stop spinning. But on the onboard experiment in the space, I think there is two possibilities. The first one is that the tip top don't stick with the water, and just spin away. And the second one is that maybe it will stick together, and the water maybe swirl around the tip top because of the viscosity of the water and also the adhesive force between two materials. So we have to like find out later. And this is the picture of the material I used. Yeah, and this is the ball, the waterproof and regular one wooden ball with this radius about like 2 centimeter, and also tip top and the white hoop, which we create the water sphere using this one. Yeah, and this is the you can look at this picture here, bigger one. Yeah, you will create like this and just push the ball to collide with the water, the first one. And the second experiment is that we will spin tip top on the water. Yeah. Okay, the result is really somewhat similar to what I expect, but there is some difference which is very interesting. I don't have picture right now, but I can explain to you. First of all, that it is very interesting that it's very, actually in the space it is hard to create this spherical water in a 4 centimeter peaks. It's hard. And it takes time a lot for the astronaut. So even the astronaut is very skillful, it's hard, yeah. And so, and by the end, we cannot stick the water with the white hoop, so we let the water floating in the air. Yeah, but we can continue with the experiments. And the result is that, so this is my expectation, but the reality is that when the ball collide with the water, no matter the mass is, all ball will pass through the water and stick at the surface of the water. So this is water and the ball is on the surface. Still stick together, but on the surface, not inside, not in the central, but at the surface. Yeah, and the depth, the volume of the ball inside the water is different, depend on the material. So it's found out that the metal ball, the wooden ball with the regular one, the volume inside the water is have the highest volume inside the water. So it's here. Yeah, but and the wooden ball with waterproof have the biggest volume outside the water sphere. Yeah. So, and the metal and the steel one is in the middle. So I think this result is due to the adhesion force between two materials, between water and the materials. Yeah. And with this experiment result, I think it's very useful for us to investigate the inelastic collision. Inelastic collision, yeah, in space. There are two types of collision, but when the two objects stick together at the end, it will be inelastic. Yeah, and because we cannot observe this thing on Earth, so it is very useful for us. Yeah. And also we can compare, we can see how surface tension of water is, how strong is it. So it's very strong that the astronaut cannot pull the ball away from the water. Yeah, it's very strong. And also we can compare the adhesive force between materials too by looking at how depth it is on the ball of the ball on the surface. Do you understand?
Probably.
Sorry. Luckily, the second experiment cannot perform because the time was not enough. Yeah. Too much work. Yeah. That's it. So, thank you.
No, thank you so much. Hi-san, it's okay?
Okay. For my experiment, I have to say for the background that why I should my study. My study is study about how water is lightened up by capillary action in a capillary tube, because I work a lot in my laboratory. I spend a lot of capillary tube for the chromatography, because capillary action is behind this experiment. Yeah, I use for the medicine quality control. Yeah, so I want to know that what will be happen if I have to conduct some experiment by chromatography. in the space. Yeah, and in my hypothesis, I prove from my equation that how different between the height of liquid such as water, between conduct from the ground compared with International Space Station. Yeah, and I think that it will be different around 1.11 time from in microgravity than Earth. Yeah, because it's less than my gravity force from Earth. This is my method. The astronaut will wire the tube, the tube in many sizes with the and compare with the ruler that how many height that water will be licensed, and everyone and astronaut can watch it together. Yeah, and unfortunately for my results, it's just easy method. But unfortunately that my result that is different from the ground conducting, because for the ground the water can rise, but for in the space the water is not rising. Yeah, no matter we have the gravity less than for the Earth, interestingly, but it can be described in scientifically. I think because it depends on confounding factor, other confounding factor like the surface between water and the tube. Because in the ground we usually use the glass material for being capillary tube, but when we have to send something to the space, we have to use something unrisky for the astronaut. So we have to change the glass material to be some plastic or polymer, because it's safer. Plastic and some polymer is more hydrophobic. Yeah, it's hydrophobic material. So I think that the surface is not less adhesion force between water and surface. So the capillary action is not appear in my experiment. Yeah, this is the result.
On-board experiment.
Yes, maybe. Yeah.
Python, did you try your ground experiment by using the plastic capillary?
Yeah, JAXA do it and send the result for me. The water can be licensed. Yeah, by using the same material and the radius size of the
How
tube.
many millimeter it rises?
Around 2 or 3 centimeter. Yeah, it's so much enough for observation. Yeah, but in the space it doesn't.
It doesn't happen.
Yes.
Okay. If the result is true, we cannot apply the chromatography under microgravity conditions.
From this result, I think we get some new thing that we have to consider about the surface. Yeah, the type of material that we can bring to use for chromatography on the space. Yeah.
Did you have any difficulty when you are preparing your experiment or during the onboard experiment?
I think it's probably difficult because first time I want to change the capillary tube in glass material to become other material, and it's probably hard to find. And the good capillary tube that can be used in the laboratory grade, that is very expensive. Yeah. So JAXA and NSTDA, consult me that maybe it's change to use some nylon or acrylic tube. Yeah, but there is not straight enough. Yeah, they have to hang it. Yeah.
Thank you for your introducing your experiment. How was the event?
Yeah, I think it's very excellent experience for me, and I'm very honored for this to really can get inside the JAXA office and also to meet a real astronaut too. Yeah, and also meet amazing and really passionate friends from around the world. it's really mean a lot for me this time. Yeah.
And for me, I have to say thank you to Wakata-san, that the astronaut that conduct our experiment. I'm very appreciate that when he calls our name. On the space, it mean for me a lot because it's likely to find a good opportunity like that. I appreciate that. Thank you.
In the future, would you like to work in the space?
Probably if I have the good opportunity like that, because I study and work in biopharmaceutical, so I think if I could be in the biopharmaceutical laboratory in the space, it will be good for me. It's very interesting.
Next, we are asked to Benson from NASA. In Thailand, it seems like they are focused on the space development. What exactly do they do?
I think in recent years in Thailand, space development is growing very well because the Thai government focus on the space development and support Thai agency and Thai Thai private company to do the space technology business. Because of space technology is the new economy for Thai people that we will use benefits from space to support the economy and the job and the opportunity for Thai people in the future.
How does the government plan about the space development in the future?
The Ministry of Higher Education and Research Innovation of Thailand, that NASA belong to this ministry, they established the Thai Space Consortium to provide the opportunity for making satellites and making some space research for support new economy for Thai people. And now the project will continue to make a small satellite by Thai University and Thai agency. For this project, NASA support about the material, and we will support Thai students to learn more about space technology. And I think it would be great for Thai people. And Japan is the good example for Thai to do the space business and space activity like Japan.
Do you have any plan to launch and deploy your satellite from Thailand?
Okay, I just heard about the Thai government will focus and set a mission for Thailand spaceport. Maybe we can build a spaceport in the southern of Thailand for launching the rocket in the future, because the southern of Thailand is good for launch rocket because close to the equator. And nowadays just a feasibility study.
It sounds very wonderful.
In the end, is there anything you were expecting to Digital Blast?
First of all, I would like to thank you, Digital Blast company, to support Thai students travel to Japan for this trip. And I hope Digital Blast company will continue support our students in the future. And we will have a collaboration about the space research in the future together. Like your equipment behind you, AMAZE equipment, maybe Thailand researcher will use AMAZE equipment for do the experiment on space.
We are our best to make your expectations.
Thank you.
Thank you so much. Thank you for your time today. It was a really good talking to you, Pai-san and Prima-san and Ben-san. Thank you so much. You are always welcome in Japan. I'm looking forward to your future success.
สวัสดีครับ